All right, we're going to pull back the curtain on something pretty fundamental to AI. We're talking about how a computer which just sees letters and code can actually start to understand the meaning of words. Let's get right into it.
I mean, seriously, think about that for a second. It's this little piece of magic we just take for granted now, right? Your phone doesn't have some giant internal dictionary telling it that king and queen go together. So how in the world does it figure that out? Well, that's what we're here to unpack.
Okay, so the secret sauce here is something called an embedding. Now, I know, it sounds a little technical, but the idea is actually super simple. Look, computers don't get English, right? They get numbers. They speak math. So the very first thing we have to do is translate every single word into its own list of numbers. We call that list a vector. That's the language the AI can actually work with.
And this is the whole point of the entire process. This is the big goal. If two words tend to hang out together a lot in sentences, like coffee and cup, then the AI's one job is to make their number lists, their vectors, look as similar as possible. Seriously, that's it. That's the entire game.
Okay, that sounds all well and good in theory, but how does it actually work? How do the numbers change? To really see what's happening, we're going to shrink this whole idea down to a super simple example and walk through it step by step.
So let's use this sentence as our training data. The AI is going to zero in on the words that are right next to each other. In this case, the pair like and apple. Just by seeing them side by side, the AI gets a hint, a clue, that these two words must be related in some way. Okay, but at the very start of training, the AI is a total blank slate. It has no clue what any word means, so it just assigns them completely random numbers. Take a look at the vectors for like and apple. The numbers are all over the place, they look nothing alike. At this point, they're basically just gibberish.
So obviously, the AI needs a way to fix this randomness, right? It needs a process to start tweaking these numbers so they actually begin to mean something, to reflect how words are related in the real world. Let's watch exactly how that happens.
And you know what? The process is surprisingly simple. It always follows these same three steps. First, it checks how similar the numbers are right now. Then it figures out how wrong that similarity score is. And finally, it makes a tiny correction to the numbers. Let's break that down.
All right, step one, compute similarity. The AI does a quick bit of math on the two number lists and gets a score. In this case, it's 0.05. Now, to put that in perspective, a score of 1 would mean they're identical, and 0 means they're totally unrelated. So 0.05, that's really low. The model is basically whispering, I don't think these two are related at all.
And that brings us right to step 2, calculate the error. Because the AI saw like and apple together in a sentence, it knows they are related. So its goal score is a perfect 1. The gap between its current score of 0.05 and that goal of 1, well, that's the error. You can think of that error as its motivation to get better. Which leads us to the most important part. Step 3, update the vectors. How does it actually fix that error? It uses a really simple rule. It just gently nudges each word's numbers a little bit closer to the other. It's like it takes a little bit of apple and mixes it into like, and takes a little bit of like and mixes it into apple. It's just trying to make them a little more similar.
So, just to recap, this is where we started. Remember these? Just a bunch of random, unrelated numbers. And then, after that one single tiny nudge, poof, the numbers have changed. You can see both the like vector and the apple vector have been adjusted just a little bit.
But did it actually work? Let's run the similarity calculation again on the new numbers. And look at that. The score went from 0.05 up to about 0.08. Now, it's not a huge jump, I get that, but it's an improvement. It's a tiny step in the right direction. The AI actually learned something.
Okay, so that's how the AI learns to pull related words together. But that's only half the story. It's just as important for it to learn what words to push apart.
And to do this, the training process also includes what we call negative examples. So for every real positive pair it sees, like and apple, it will also generate a random incorrect pair, something like and car. Because, in the real world, you just don't see those two words together very often.
And here's the beautiful part. For the related words, remember it adds a little bit of their vectors together to pull them closer. But for these unrelated negative examples, it does the exact opposite. It subtracts a little bit to actively push their vectors apart. This is how it makes sure apple gets closer to like, while car gets shoved into a totally different neighborhood.
So what we just saw was one single update, just one tiny nudge in a sea of data. But what happens when you do this millions or even billions of times?
Well, the AI just keeps repeating that simple three-step loop. Compute similarity, calculate the error, update the numbers. And it does this over and over and over again. For every pair of words, in every sentence, across a huge chunk of the internet. It's a very simple process, just repeated an absolutely astronomical number of times.
And after all of those tiny nudges, something incredible starts to happen. A kind of order emerges from the chaos. The number list for apple ends up looking almost identical to the number list for banana, just because they tend to show up in the same kinds of sentences. Meanwhile, the vector for car is miles away in a completely different numerical space. This is it. This is meaning, emerging from pure statistics.
So really, if there's one thing you take away from all this, it's this simple idea. The entire seemingly complex process of AI learning language just boils down to this fundamental push and pull dynamic, pulling related things closer and pushing unrelated things apart. That's the engine that drives its understanding.
You know, here's a really great way to picture it. Imagine every word in the English language is just floating around in a big empty space. And between every word, there's an invisible rubber band. Every single time the AI sees two words together in a sentence, it gives that rubber band a little tug, pulling them just a tiny bit closer. And at the same time, it lets the rubber bands between unrelated words go slack so they can just drift further apart.
And that right there, that's the one-line truth. All of this incredible complexity, all of this what feels like AI magic, at its core, it's really just the simple act of adjusting numbers over and over and over until the number lists for words that mean similar things start to look similar too. It's kind of wild when you think about it. This incredibly simple mechanism, just pushing and pulling numbers, is powerful enough to teach a machine the meaning of human language. It really makes you wonder, if it can learn this, what else can this fundamental process be taught to understand?